Hello and welcome to my video on proof writing. My name is Cadet Emily Curry and today we will be discussing simple proof writing, and I will show you how to prove a simple statement. So first off, what is a proof? A proof is a way to logically show that a statement is true. And so how is learning about proofs different from other math classes that I've already taken? The big difference is that in proof writing, there is no answer. It's more a process where you show whether or not something is true. So, how do you prove something? Well, thankfully, my professor, Professor Thomas, wrote an amazing proof guide to walk you step by step how to do a proof. So first off, you write the question that you're trying to prove in an if-then statement. So what I'm trying to prove is that if A, B, and C are sets in the element of real numbers, then f of A and B or C is equal to f of A and B or f of A and C. So that's what I'm going to be proving today. So the purpose of this is to just kind of clarify the problem, right? So that everyone knows exactly what you want to prove. So the second step is, what do I know? So this is just the words between the if, then, and the then. So I know that A, B, and C are sets in the element of real numbers, right? The purpose of this is to just state your assumptions and kind of give you something to work with and a place to start. Right? Okay, so step 3. What do I have to show? So this is what I want to prove. So I want to prove that f of A and B or C is equal to f of A and B or f of A and C, right? So the purpose of that is to kind of get an idea of where you're going. So number 4, expand on what you know. So this is the purpose of this is to kind of give you something to work with and a place to start. This can really help when you get to actually proving the problem. It also helps when you want to know what certain things are. So one definition we have is the definition of a function. So the definition of a function of sets is where you let x and y be sets and let f map x to y be a function. This means that if x1 equals x2 in the element of x, then f of x1 equals f of x2. So the image of a set D is defined as f of D is equal to y in the element of y, where f of x equals y for x in the element of D, right? And you would also write down any theorems or expressions you think could be helpful later on in the problem. My question specifically said I'm not supposed to rely on any existing theorems, so I'm not going to put anything there. So now expand the show. So the purpose of this is to give you more things to work with, right? And one thing I wrote down is the definition of set containment. So that means that if A and B are sets in the element of real numbers, then A equals B means that A is contained in B and B is contained in A. So when you're proving anything with sets, it's normally going to be a two-part proof if you're proving equality, because you have to prove it both ways. So that's all I have for my show. So now we're getting into how to actually prove this problem. So first, I'm going to do some algebra with this. And so A and B or C can actually be changed into A and B or A and C. I have proved this in my lemma 1 that I know that this works. So a lemma is like a small proof that is a side to a larger proof. So I can go and prove that this is true without wasting your time explaining why it's true and going through all the steps for that. This is also called the distributive property of sets. I can show you lemma 1 later if you ask. So now that I know that, then I know that f of A and B or C is equal to f of A or B and A or C. A and C, sorry. So since I have this, now all I have to do is show that f of A and B or A and C is equal to f of A and B or f of A and C. Sorry. So I just have to show that now. That simplifies the problem a lot. That's what a lemma can do. So to simplify this problem further, I'm going to say that A and B is equal to C. No, sorry. A and B is equal to E, and A and C is some set called F, right? So if this is true, then now my problem becomes, does f of E or F equal f of E or f of F? And it just so happens that I've done another lemma, lemma 2, that shows that this is true. So since I know that this is true, and I know that this is true, then the 3 dots mean therefore f of A and B or C does in fact equal f of A and B or f of A and C. This is true. So now that we've discussed the logic behind the proof, I'm going to show you an example of this proof cleaned up. So for my clean proof, I will let A, B, and C be sets in the element of real numbers. I will show that f of a and b or c is equal to f of a and b or f of a and c. I will start with f of a and b or c. Using my lemma 1, I can simplify this to f of a and b or a and c. This is also called the distributive property of sets. For my next step, I will let a and b equals e, where e is a set in the element of real numbers, and a and c equals f, where f is a set in the element of real numbers. So now I have f of e or f. So using my lemma 2, I know that f of e or f is equal to f of e or f of f. And since f of e or f of f can be rewritten as f of a and b or f of a and c, I have proven that f of a and b or c is equal to f of a and b or f of a and c. So now that we've proved that, my professor has so graciously assigned me an extra part to my proof, which is to prove f of a and b or c is equal to f of a and b or f of a and c, which is equal to, and here's the new part, f of a and f of b or f of a and f of c. So I'm going to restate this problem in a slightly less confusing way. And the new part is that I can change f of a and b to f of a and f of b. So what I want to know is, does f of a and b equal f of a and f of b? And if this is true, obviously this part would be true as well, right? So this is, in fact, not a true statement. And I'm going to show this by providing a counterexample. Counterexamples are really useful because they're basically the easiest way to show something is not true. So my example is that f of x equals sine of x. So I'm going to let A be some set that includes 0. It can include other things as well, but it includes 0. And B is some set that includes pi, right? And we all know that sine of 0 equals 0 and sine of pi also equals 0, right? So if I do A and B does not include 0 or pi, right? Because A has 0 and B has pi, but B does not have 0 and A does not have pi. So A and B does not have 0 or pi. Therefore, f of A and B also does not include 0 or pi. Moving on, I know that f of A does include 0, right? Because A includes 0, then f of A also includes 0. I also know that f of B includes 0, since f of pi is 0 and B includes pi. That means that f of A and f of B includes 0. And since this includes 0 and this one does not include 0, they are in fact not equal. So that's just a fun little example to show. Thank you for watching my video. I hope you enjoyed it.